Hello, my name is Joe Karsha, NJ1Q. I am the station manager here at W1AW in Newington, Connecticut. W1AW is the Max Memorial Station and headquarters station for the American Radio Relay League. The purpose of today's video is to show you how to assemble the Cushcraft A14820T 2-meter antenna. The A14820T is a 10-element crossed Yagi antenna for use on 2 meters. It is this antenna that you will use as part of your primary station for contacting the astronauts aboard the International Space Station. When you receive the antenna, you will receive all the elements, in addition to the boom, as well as a rotator, an elevation and azimuth rotator setup. For the purpose of this video, however, we will be showing you just the antenna. So there are some pieces that will be exaggerated in how they are mounted and so forth. Now, as you will see with these elements, each one is marked for your convenience. Now, for the purpose of this assembly, you will need some very basic tools. In this case, a pliers, a Phillips head screwdriver, and a blade screwdriver. Here we have the elements themselves of the antenna as well as 2 of the boom pieces. As you can see, the boom pieces are marked front to back, with the center being marked as the middle. For the purpose of this video, we have this mounted to a tripod. Please note that while you'll be using this tripod, you will not be using this particular section. Rather, there will be an elevation azimuth rotator connected to this, which will actually control the position of the antenna. That will be covered in a later video. When you receive the antenna and its pieces, you will note that the boom to mast plate is already connected to the antenna boom. It will be physically attached. You will not need to either change or remove this boom or mast plate. The only assemblage here will be the connection to the actual boom, which will be on the rotator. Again, for the purpose of this video, this is attached, but please note this will already be assembled and attached to the middle boom section. To begin, you will want to add what is called the back of the antenna. Now let's go over a few things. As you will notice, there are large holes and there are small holes. These allow for the mounting of the various elements. Each element consists of the element itself, a small saddle and clamp, and a screw. As you can see, each boom element has a larger hole and a small hole. The larger hole is used to accommodate the lock nut, and the small hole is where the screw will pop out and where you will place the wing nut. You want to assemble the boom section first. It has been reconfigured to where the assemblage is rather easy. Here we have the middle boom, it says middle, and here we have the back. On this you will find a regular pipe clamp and another screw and washer, or rather lock nut. Remove the screw and the wing nut and just put it off to the side for a second, and take the element and slide it in. You'll see there's a hole here and here. Slide them together until they match up. If done correctly, not only will the hole match up, but you will see the small black line will meet right at the edge of the center section. Quickly clamp the pipe clamp right at the end so as to put compression around this. In addition, you want to get the screw and the wing nut, put it through, and give it a quick tighten. You want to start from the back, or in this case, the reflector portion of the antenna. You know you've done it correctly when the vertical component of the antenna is first and the horizontal is second. Again, so long as the back, middle, and then ultimately the front are all in the same line, you know that this portion has been assembled properly. As we mentioned earlier, everything is marked. This is V1, the vertical element. Remove the wing nut. Place it into the boom. And secure it like so. That is V1. We now take H1 and do the same thing. It does not matter which side the tape is on. These are symmetrical elements. So as you can see, I have V1, H1 here. It could be like that. It does not matter. Next comes the driven portion. As with these elements, these are also marked H2 for horizontal and V2. You can put V2 first and then H2. And it does not matter necessarily which ones you put on first. You can do all the horizontal first and then do the vertical, or do it a step at a time, whichever you find is easier for you. When it comes to the driven element, the only thing you want to ensure is that the connectors, these are the UHF connectors, are going in the same direction. So while you see we have the vertical component here, and this is the horizontal, both connectors, in this case, are pointing towards the front of the antenna. It is here where you will make your connection for the antenna, and that will be covered under another video. We will continue on with the V3 and H3. In this case, I have the H3 here, just to show you that it essentially does not matter which one you place on there first. Just make sure they're tightened. Since this antenna will be outside, if there is a little bit of wind, you don't necessarily want these antennas being whipped around, so just make sure they're tight. You can make them finger tight, or again use the pliers to add a little bit more to it. And finally, V3. Now one thing you want to ensure is that you have the antenna balanced and you have the other elements on there. Otherwise, this is what's going to happen. The antenna is going to want to do this. It's going to want to move on you. So ensure that everything is secured beforehand. As mentioned earlier, you want to ensure that you have all the elements assembled so that the antenna will be balanced. For time's sake, I've already added the front of the antenna. Like with the rear, you slide it in. It can only go in one way, as well as the mounting hole will match up. You place the screw in there, tighten the clamp near the edge, putting enough compression to hold the element in place. Assembled correctly, you will have back, middle, and front all going in one direction. In addition, the safety sticker is located near the front of the antenna. And we encourage you to follow the safety procedures. This antenna will be outside for tracking. Ensure that it is free of any wires or other obstacles that may get in the way of the antenna for either its positioning or for safety. You do not want this near any low-hanging telephone lines or power lines or anything of that nature. In the interest of time, we have assembled the antenna completely. As you can tell, we have the reflector section driven all the way to the directors. You'll also notice, as mentioned earlier, that it does not matter where the labels are located. The only thing you have to be sure about is which element is where. We'll now tend with the feed point. As you can see, there are two connections. However, you will only be having one length of coax, which will be sent off to the radio. What we have is the small adapter. Essentially, this is a simple matching network with a quarter wave length of coax here to ensure the antenna is out of phase. It does not necessarily matter which connector you use. You can put the green on top or the green on the bottom. You do want to ensure that the connection is strong and tight. You also do not want to put too much force on the coax lines. You will be supplied with a length of black tape. For this demonstration, we're just using this double-sided Velcro to give you some idea as to how you want to hook this up. You will feed the coax. The coax connection will be here. You can bring it along down and run it through the mast. You do have to take into account that this will be on an elevation and azimuth rotator, so ensure that you have more than enough coax to allow the antenna to move both horizontally and vertically. In this portion of the video, we will show you how to assemble the Yaesu G5500 elevation and azimuth rotators that will be used to control the position of the Cushcraft A14820T antenna. As you can see, the system consists of an elevation rotator. Underneath that is the azimuth rotator, followed by the tripod in which all this will be mounted. Please note that at the bottom of the tripod there are three support pieces, angle brackets. This is where the users must use either sandbags or cinder blocks to hold down the mast to keep it from tilting over. While the system is relatively balanced, since this will be outside, the slightest breeze can tilt the system over since a lot of the weight is located near the top. As you can see, we have marked the tripod with an N for north. We highly recommend that during the installation of the rotators, you position the tripod to point to geographic north. Not geomagnetic, but geographic north. This is critical for proper tracking of the International Space Station. You'll notice here that there is a mounting hole as well. This too is critical in the position of the azimuth rotator. This has been set up to where the rotators will go in only one particular position. Be advised that as you build this up, it will become heavy. It will become top heavy. So again, we cannot stress enough the use of sandbags or cinder blocks at the base of the tripod before you do any other installation. The first rotator to put on is the azimuth rotator. You will notice that it is marked with an N for north. You will receive this rotator with it at its north stop. The rotators, both the azimuth and the elevation, will be properly oriented when you receive the package. When installing it, put down this locking clip. Place the rotator, up. Place the rotator in the position. Before fully locking it, ensure that these line up. There is a hole here, and there is also a hole inside the mast. This is where you install a 1/4-20 bolt. It is pitched in one direction. Again, this is to ensure that it will only go in one way, thus setting the north setting on the rotators. Now on the mast clamp, there are actually 9 bolts you will be adjusting. There are 2 on each side of the mast clamp itself, 2 on each side on the upper portion of the mast, and there is a bolt that goes through the center of the boom, the mast that will be holding the elevation rotator. The hardware that you will use will be supplied. This is a little tight, so don't be too discouraged if you find it's a little difficult going in. We highly recommend that you not tamper or try to make the hole a little larger. Again, it is a regular 1/4-20 bolt. You can either hand tighten it or use regular hand tools. When completed, just put this clamp down. That compresses and secures the rotator. Now for the next part, you will probably need a step stool or a sturdy ladder. As we always mention through these videos, safety is first. So we recommend you not use something that would be incredibly unstable because, again, there's going to be a lot of weight up here and this thing can tip rather easily. The next up is the elevation rotator. This will only go on one way. You will notice that on top of the rotator it says up. Essentially, the rotator will be mounted like this, again in line with the two north points. You'll see there is a hole here. It is this hole that will be passed through here where another mounting bolt will be secured. For the purposes of this video, I will not be standing on the chair, at least for the mounting of this piece. It's an Allen head screw. You'll notice that there are lock washers on both sides. Take it, mount it, match up the hole. Again, you will find this will be a little tight. Again, we recommend that you not alter or change the holes in any fashion to make the mounting easier. While you will be clamping down the mast, both this bolt and this one keep either rotator from twisting. Once that is secured, you can now tighten the bolts. We recommend that you tighten the 4 horizontal bolts first, ensure that they're snug without necessarily crushing this mast section, and then tighten these 4 bolts here. They have to be tight, but you do not have to over tighten them. If you do, you risk stripping the threads inside the rotator. All you're needing this to do is to be sturdy and tight without necessarily damaging the threads on either rotator. Once you have both rotators properly secured, next will be the installation of the boom. The boom will hold both the antenna as well as the counterweight. The boom consists of a non-conductive material with metal sleeving to allow for proper clamping. This is where safety is very critical. Assuming you need a step ladder, you will be raising yourself above the rotators and the tripods. So again, take heed. The boom will be mounted with 2 clamps to the elevation rotator. It is not critical necessarily how this is mounted into the rotator, so long as this is centered within the elevation rotator itself. Place the clamps on either side of the elevation rotator. You will find they will be a little tight, and that is acceptable. If you find they are too tight, it is acceptable for you to slightly bend them by hand. Do not use any clamping devices to open them up and get them down the saddle. On the rotator, there is an open side and a closed side. You will notice that there is a ridge here. It is here where the round portion of the clamp goes. For the purpose of this video, we will not be completely securing these, rather making them finger tight. For your installation, however, you want to ensure that these are properly tight. Not so much to necessarily strip out the U-bolt or dig into the aluminum sleeving, but rather to keep this from moving. Since you may be reaching, again, safety, safety, safety. Once that is secured, it is now ready for mounting of the antenna and the counterweight. The counterweight essentially does just that. It provides a counterweight to counterbalance the weight of the antenna. If the counterweight was not present, this will be off-balanced and risks tipping. The counterweight is approximately 8 pounds. It has already been adjusted to where it needs to be on the boom. While we will not mount this because we will not have the antenna on the other side, note that it goes opposite the antenna. It also has to be in line with the antenna. In other words, while in this video it is mounted and it will be vertical, please note that once it's installed, it will be horizontal with the antenna. Now you may find it easier to have the antenna, which is going to be pre-assembled prior to the assembly of the rotators, to be temporarily attached to one end of the boom when attaching the counterweight. As you can see by the counterweight, there is one side that is larger than the other. You may find, depending upon your installation, that you will have to adjust it either this way or that way until the antenna perfectly balances. As mentioned earlier, the counterweight and the antenna must be parallel to each other. In addition, since the rotator, as you receive it, will be set to 0 degrees elevation, ensure that both the antenna and the counterweight are also at 0 degrees elevation. If you're not sure, you can use a line level or regular level to ensure that the antenna is nearly flat. That is critical since the tracking depends upon the actual position of the antenna. Even if it is off by a few degrees, you may find a slight degradation in signal when the time comes to track the International Space Station. Once the antenna and the counterweight are properly installed and you feel secure with the installation, that the antenna nor the counterweight will move at all when this is in motion, next will come the installation of the cable. You will be receiving various lengths of cable depending upon your particular application. The lengths of cable will be to a maximum of 400 feet. There will be 2 connections, one for the elevation and one for the azimuth. The cables are also marked accordingly to make for ease of installation. The cable will be marked either red or yellow for elevation and azimuth. There are 2 ways that you can have the cable dangling. You can either have it loose, free-forming off the rotators, or if you feel you might be in a slightly windy situation during the contact, you can secure the cable loosely right here at the bottom. You must ensure that there is more than enough rotator cable to allow the antenna to swing 360 degrees. If the cable is too tight, you risk pulling it or damaging the connector or impeding the rotator from moving. It is very critical that these lengths be long enough to allow for movement. We cannot stress that enough. Once the cable connections are made, they will then be brought over to the controller box, which will be handled later in the video. Now, for the purpose of this video, again, we will not be mounting the antenna, and I will be removing this. Again, always being mindful of how much weight is above here. When taking off either the antenna or the counterweight, ensure that someone is properly holding this so the antenna or the rotator system does not tip over. As you can see, for the purpose of this video, we have already attached the elevation and azimuth cables. You will notice that they are color-coded. The elevation rotator has a red tag on it, and the azimuth has a yellow. In addition, the cable is also marked. In this instance, this is a 100-foot section of rotator cable for the azimuth rotator, a 100-foot section of elevation rotator cable. At the end of these cables, there are Jones plugs, 6-pin Jones plugs. This length of cable is 100 feet. If you find that you may need more, that will be supplied to you as part of the shipment. And there will be connectors along the way to daisy chain these cables to make them longer. Please note that while it isn't readily seen, these cables, or rather these connectors, do have a particular pinout. On the back of the rotator controller, there are also Jones plugs. In addition, you can see that they are also color-coded. We request that you not change these connectors, nor interfere with any of the terminals in the back. To do so risks either damaging the rotators or the controller, or at a minimum, not allowing the rotator to properly track. Once you have the installation of the cables, antenna, counterweight, you are satisfied with the proper securing of the rotator, it is properly oriented towards geographic north. When this is completed, then feel free to make the connections. As mentioned, these are keyed in only one direction, and they will only go on in one proper direction. You should not have to force these on. If you find you are using excessive force to put these on, chances are that it is twisted. Red into red, yellow into yellow. As an example, I can readily see how this is properly keyed. This is opposite. This will not go in properly. Turn it around, it pops right in. This again is critical. Put it in properly, you do risk damaging either the rotator or the controller box. The controller box is the ACG 5500. It allows you to move the elevation or the azimuth rotator using these buttons. For this project, you will be automatically tracking the International Space Station. You will not be using these 4 buttons, and that will be discussed later in the video. To test it, merely turn on the power. The elevation, since it is in its rest or down position, you hit the up button, and as you can see, the rotator begins to turn. Go down, and it should rest. We recommend you test to ensure that the antenna and counterweight move freely. We will now test the azimuth. As mentioned earlier, ensure that you have the proper length of cable. If this is too tight, for example, and you try to move this, you risk damaging the cable and putting undue stress on the azimuth rotator. So ensure that you have a decent loop of cable, especially on this particular rotator, but also on the azimuth rotator. Please note that during the installation, if there is a significant breeze, again, going back to the proper securing of the tripod, but if there is a breeze, you may notice that this sounds as if it might be struggling. That is acceptable so long as there is not a strong breeze which would actually keep the antenna from moving properly or risk toppling it. For this part of the video, we will show you how to properly connect the antenna controller, its interface, and laptop for use for the tracking. Aside from the two rotators, these three pieces include the rotator control console, which we showed you earlier, its computer interface along with its own USB cable, and obviously the laptop. While it is acceptable to power up the laptop, do not log into the laptop until this equipment is installed first. Now, if you look behind, you see the two cables which run to both the elevation and azimuth rotator. Off the interface, you connect the 8-pin DIN to the back of the control console here. It is keyed, so it can only go in one direction. It should pop in properly and without any excessive friction. Please note, however, that these cables are extremely short, and this is done purposely. We highly recommend that you not put any undue force on these cables or even its own USB interface out of risk of damaging either the cable or the USB interface. You'll also notice that actually plugs in. Ensure that that is in there properly. Once you have the control console, the rotator interface, and the USB attached, you're good to go. One note, you will see that this USB port has been marked. For this setup, you must use this USB port for proper operation. If you do not, you will get an improper COM port assignment and the tracking program will not function. Please note also that you will not be supplied a mouse. If you need to use the mouse, as opposed to the touchpad, feel free to use any one of the other free USB ports. We cannot stress enough that this USB port must be reserved solely for this controller. When the computer boots up, you will see two icons. You wish to connect to the icon that says ARISS. The password is ARRL. When the computer boots, it will immediately go into SAT PC32. SAT PC32 is the program that you will be using to track the International Space Station. The program will be configured with your particular location. For the purpose of this video, as you can possibly see, there is an X there, which is our location here in Newington, Connecticut. When you receive this equipment, an X will appear over your particular location. Prior to you receiving this equipment, your location will be pre-programmed into the software. You will not need to configure the software for your location. That will be done for you beforehand. When you receive this, there is one thing that you will need to do, and that is to update the Keplerian elements. That is critical as well for proper tracking. Now, before we do that, please look and see that the program says ISS. And based upon our location here in Newington, Connecticut, that is where the International Space Station is currently located. This is based on current Keplerian data. Again, when you receive this, ensure that you have a Wi-Fi connection and that the laptop has properly connected to that Wi-Fi connection. And feel free to use the proper configuration to connect to the Wi-Fi setting if necessary. If you do not have a Wi-Fi setting, but rather a regular Cat5 hardwired internet connection, please feel free to connect the laptop to that system as well. We do ask that you respect the laptop and any of the software programs that are on it. Do not add any additional software or remove any additional software or reconfigure any of the programs. In addition, we ask that you ensure that if you are making a connection to either a server or to a Wi-Fi, that there is some form of protection available. That protection could be in the use of firewalls or virus. Otherwise, the software will be set up for you. Now, again, you must update the Keplerian elements prior to tracking. As you can see, you wish to go up to Satellites. A window will open up that says Satellites. You will see source files, various types of satellites, and again, these are amateur. Over here on Selected, you will see ISS. Because again, the program is set to track the International Space Station. Go down and click on Update KEPS. The first line is going to, as you may be able to see, amsat.org and nasa.ol. Click on Download. Assuming you had a proper internet connection, you should get download successful. Click on OK. Click on Quit. And click on OK. Because the system will be set up beforehand for you, chances are you will not see the ISS move significantly, because as part of the installation process of your location, we will be updating the Keplerian elements for you. But again, to be safe, we recommend that you update them when you receive the laptop. The software, SAT-PC32, shows the location of the International Space Station. It will show your location with a small plus sign, as can be seen here, and it will show you a window. This window says ISS. It also shows you the acquisition of signal, or AOS, or loss of signal, or LOS, and the maximum elevation. In this particular demonstration, we are seeing that for our location, the ISS is not going to be overhead for another 9 hours. And when it is, the maximum elevation is only going to be approximately 60 degrees, or 6 degrees rather, above the horizon. Obviously, for your particular contact with the ISS, that elevation will be much higher and it will be more in line as to when your demonstration to the students is taking place. You will also see down here some data. This is the information that will be sent to the rotator controller box or control console. It shows azimuth elevation, the current height, as well as your acquisition and loss of signal times. We recommend that you use this information in demonstrating to your students the various position of the International Space Station and what this data represents. Assuming this is set up properly, when you turn on the controller and it is time for your ISS contact, you will begin to hear the rotator controller clicking. Essentially, it is sending voltage to the rotators. And if you're in visual side of the rotators, you will be able to see the antennas move. It will pre-position itself. You will not need to adjust any of these buttons whatsoever. If you find that the ISS is over your location and this is not tracking, check your connections. Aside from any catastrophic failure, that would be the only reason why you are not properly tracking once the ISS comes over your location. This is the International Space Station and its footprint. Essentially, this is what the ISS sees representative to its particular location. AOS, or acquisition of signal, occurs when this line right there crosses over your particular location. Approximately 1 minute before this line crosses over your location, you should hear the controller begin to control the rotators. This will maintain its position as well as control the rotators until the pass ends. The pass ends once the other end of this footprint passes over your location. So long as your location is within this footprint, you will be tracking the ISS. Once the pass is complete, once your ISS contact has been completed, merely shut down the program by clicking the X. We also request that you home or reset the rotators. After the pass, this is where you can now use these buttons here. You want to use the down button to level off or set at 0 elevation your elevation rotator. And depending upon where this is located, you want to use the left button to bring the azimuth rotator to 0 degrees. It is possible that depending upon your particular location and where the ISS was moving, that this may be very close to home. Even if it's a few degrees above 0 in either rotator, we still recommend that you home both, again using the down and the left buttons. Once that is completed, you merely turn off the unit. When this is done, you shut down the program and you shut down the laptop. When disconnecting, we recommend that you disconnect the AC power to this prior to removing these connections. Remove these connections and carefully repackage them, noting, again, that these are very short pieces and they're relatively fragile. In this part of the video, we will show you how to hook up the equipment that you will use to make the actual connection with the International Space Station. You will be supplied with the Yaesu FT857 HF and VHF transceiver, a Mirage B5018G amplifier and preamplifier for 2 meters, as well as an Astron RS70 linear power supply. The transceiver and amplifier will connect to the power supply using Anderson power pole connections. The connections will already be located on the power supply, and both connections on the preamplifier and the Yaesu have the connections on them as well. You do not need to reverse engineer or make any other changes to these power connections. The power supply is rated to handle both the amplifier and transceiver simultaneously. Now, while you see that this is hooked up rather quickly, we highly recommend that when you do install this equipment, the power supply located near the setup without actually being in the way. In addition, we have the connecting coaxial cable that goes from the 2 meter and 70 centimeter side of the transceiver to the radio input of the amplifier. The output of the amplifier, or antenna, will go to the coax length that you will be supplied with. As you can see, this particular one says 100 feet of coaxial cable. Depending upon how much you will need, up to a maximum distance of 400 feet, you will be supplied with the appropriate amount of cable. We recommend that you use the preamplifier, and as you can see on the front of the amplifier, the light for preamplifier is lit. The corresponding buttons here either activated or deactivated. Since you will be using FM, you want to ensure that the amplifier is in FM mode. Please note that the uplink frequency to the ISS for school contacts is 144.490 megahertz with a downlink of 145.800 megahertz. The appropriate frequencies will be pre-programmed into the transceiver prior to you receiving it. It will not be necessary to adjust any of the settings on the transceiver. That will be done prior to you receiving it. If your school is also capable, we'll be providing you with an audio interface box. While it looks a little menacing, it is relatively straightforward. This box will allow you to take audio, both transmit and receive audio, from the transceiver and direct it into your school's PA system. Unlike this setup where the microphone is attached directly to the transceiver, if this box is sent, if it is required, the microphone will be plugged into this audio interface box, with the box plugging into the transceiver's microphone jack. There is a connection that will go to the audio out, or the speaker out of the transceiver, with two standard 1/4-inch stereo jacks to plug into your school's PA system. The lines are isolated. Audio levels will have to be adjusted at the school's PA system point. You may find you will need to adjust the audio level of the transceiver to avoid excessive distortion. For additional information on how to use the memories during the course of your QSO, please refer to the written instructions which will be included with the transceiver and the other equipment sent. Once your school contact has been completed, we ask that you please power down all the equipment. In addition, we ask that you disconnect all the equipment properly and properly pack it in the containment vessels that were sent to you in preparation for sending it out to the next school for their school contact. We hope you find this instructional video informative and helpful. If you have any questions on the setup or the equipment, please feel free to call me during regular business hours, Monday through Friday, 8 a.m. to 4 p.m. at area code 860-594-0208. I'm Joe Karsha, NJ1Q, Station Manager here at W1AW in Newington, Connecticut, 73.